f prime of a. Awesome. So y minus f of a equals f prime of a times x minus a. I will distribute, move f of a and solve for y. So f prime of a, it can stay as x minus a, and then plus f of a equals y. It can also be written, we like it like this, however, f of a plus f prime of a, x minus a. This is what is called a linear approximation, so I can write it as approximate. Also, L of x is called the linearization of f of x near a, x equals a. And this is L of x, f of a plus f prime of a times x minus a. And also we can say that the function is approximately f of a plus f prime of a, x minus a, and this is the linear approximation. Linear approximation near a. Okay, so L of x is the same thing, f of x approximately the same thing with these two. That's all it means. And now let's start with Isaac's question. Let's see. I'm assuming that this is something that he had in mind. Let me see if I can open this. Let me see, did it open? Where are you? Okay, I managed to lose everything. Let's try again. Ah, it did open. Excellent. Verify the given linear approximation at a equals 0. Then use the graphing calculator computer to determine the values of x for which the linear approximation is accurate to within 0.1. Okay. Perfect. Oh, I didn't share my screen. Let me share my screen. Perfect example. Let's start with that. Perfect. Let me copy it and then I'll stop sharing. So we have the fourth root of 1 plus 2x, let's say, is approximately 1 plus 1/2 x. So first of all, it says, verify the given linear approximation at a equals 0. Okay, so let's do that and then I'll come back for the rest. So I don't know what that is, but I do know that I have a function, f of x, which is the fourth root of 1 plus 2x. I know that f of x is approximately f of a, in this case a is 0, I'm going to write it again, plus f prime of a times x minus a. And now I'm replacing a by 0. I wanted to show the definition first. And now I'm replacing it by 0. F of 0 plus f prime of 0 times x minus 0. I'm just going to say times x. This is our function. When I plug in 0 here, what do I get?
One.
Excellent. Now I have to plug in f prime, but I don't have f prime yet. So let's determine f prime. So remember, for f prime, we should always do this first. Which power? For this function, of course.
Negative 1/4.
Careful.
Or sorry, 1/4.
Very good. Awesome. So then f prime of x, I bring down the power. I subtract 1 from the power. What do I get when I subtract 1 from 1/4?
Negative 3/4.
Excellent. Times the inner function prime, which is
2.
Excellent. So 2 divided by 4, so I will have 2 in the denominator. And this can go to the denominator as well as the fourth root of 1 plus 2x to the third power. Remember where I am. I'm right here. I have to plug in 0 here because I need to find f prime of 0. I found f prime. I'm happy now, but I have to plug in 0. So how much is f prime of 0? I
1
think
over 2.
my finger hurts. Thank you very much. So this is 1/2 times x. So plus x over 2. Now, correct. It's 1 plus 1/2 x and 1 plus half x, the same thing. Good. So we verified that that was correct. This was the first part of the problem. Any questions so far on this? Isaac, is this okay?
Yeah, it's okay. Thank you.
So far. Okay, no, but there is a second half of the problem, or the second part. Then use a graphing calculator or computer to determine the values of x for which the linear approximation is accurate within 0.1. Aha. So now they want this, and could be equal. They want this minus this, the error of the approximation, this minus this, to be less than 0.1. So now I have to be careful here. I cannot solve this by hand, but we have to start it, get it started. Anyone remembers the absolute value of x less than or equal to 4? How does, as an example, how does this change? So I can solve it. This I cannot solve. I have to change it into something simple or simpler. How do I change this? How do I solve this? So now I drank my water and I can explain again that draft thing. It was interesting.
The x minus 4.
Negative 4 less than or equal to x less than or equal to 4. So this is what I need to apply over there, right? So negative 0.1 less than or equal to the fourth root 1 plus 2x minus 1 minus 1/2 x less than or equal to 0.1. Okay, good. Interesting, interesting, interesting. So now I am going to solve this one first.
Sorry, can you go up a little bit?
Like this?
Yeah, that's fine.
So first I am going to solve this, and then I'm going to solve this. I cannot solve both at the same time. So I'm going to solve this inequality first, and then I'm going to solve this inequality with the graphing calculator. So we'll plug it in a moment. Let me see if I can do anything else here. So the fourth root of 1 plus 2x minus 1.1 minus 1/2 x less than or equal to 0. Okay, so first I have to solve the equation when it's 0. So I'm sharing my screen. No, I'm not sharing my screen. I'm trying to. Okay, so in y equals, clear, and we will enter in parentheses 1 plus 2x power, and of course in parentheses 0.25, that's my quarter, minus 1.1 and minus 0.5x. I need to find the x-intercepts. Okay, so if I go to graph, standard. Standard. I want standard. Standard. Okay. What is happening here? Gee whiz. So let me zoom in. Let me zoom in and see what happens. Aha. Okay, much better. Oh, so according to this, there is no x-intercept. Fine. So this will never touch the x-axis. Okay, so this will always be negative, always, for all x, where the function is defined, which means 1 plus 2x has to be greater or equal to 0. Okay, so now I'm going to try the other one. I'm going to stop sharing. So I'm going to say that this is always true because this piece is always under y equals 0. So this happens always, of course, only as we know, this is an even index. This quantity, I know no one likes that, has to be greater than or equal to 0. Okay, so this was this one. Now I have to look at this one. So I have the fourth root of 1 plus 2x minus 1 minus 1 half x plus 0.1 greater than or equal to 0. So this, I'm moving it, is positive 0.1. So now we have the fourth root of 1 plus 2x minus 1 half x, and this is minus 0.9 greater than or equal to 0. Now I need to graph this one. Interesting, very interesting. I'm sharing my screen. So let's go to y equals. I'm going to leave that alone. I'm going to create the second one as 1 plus 2x in parentheses again, power again, the same thing. And then again, I have this time still, I have negative 0.9 and then minus 0.5x. Okay, fine. So I want to graph. Aha. Okay, so here's what happens. So I need to determine these two. Let me zoom out a tiny bit. Can I zoom out a little bit? Not too much. Okay. Okay, so when I solve the equation, so it is greater than 0 between these 2 points. Okay, so let me zoom in again for everyone to see better. Don't do that to me, please. Okay, so I need to determine this point and this point where the red graph intersects the x-axis, this and this. So second and calculations, and I go to a 0. And let me do this. I don't need the first one for a second, so I'm just going to de-highlight it. So it's out of there. So second and calc, I want the 0. I will only see the red now. And the left bound, no, I want the left bound a little bit more. I want pass. Yep, that's where I want the left bound. And then the right bound, I want to pass the intersection. Yes, done. Okay, just give it to me. So x equals negative 0.368935. Now I want the other one right here, this one. Again to second and calc. I want the other 0. No, that's not the left bound. I want this left bound. And I want pass the 0. Pass, pass. The right bound, just give me the number. Okay, so x equals 0.67766692. Okay. So back to our problem. Where is my problem? Right here. No, right here. So round your answers to 3 decimal places. So see this symbol? We used it before. Let me explain it. So remember we said x in the interval, this and this. negative 0.368935, comma 0.67766692, and I will use what they want me to use. So this is the symbol that says x is somewhere, anywhere in this interval. So back to sharing.
I think it,
I couldn't hear you. Was someone talking to me or not? Well, I don't know what to do next. So, Isaac, is this okay?
Oh, my thing was on. I was looking at the video from it.
So did you enter the answer?
I want to write it down first.
Sure. Do you understand what happened here?
Yes.
So the first inequality has has all solutions possible, but the second one is restricted between negative 0.368935. They want 3 decimal places. So you will have to enter negative 0.369, comma 0.678. This has to be entered like that. So enter left parenthesis, negative 0 point if you want, 369, comma 0.678. Let me know when you entered it. Very good question. And then I would like to choose another problem from the linearization or the linear approximation. What did it say? Did you get it? Should I still wait, or what do I do?
I'm still typing it.
Oh, okay. I'll wait. Sorry about that.
I think I mean,
it's not easy getting stuff into WebAssign. When you gotta
Yeah,
do
yeah, it's
something
not very
else.
friendly. I agree. Did it work? Let me know.
yes, it worked.
They accepted the answer like that?
Yeah, accepted it.